All right. Welcome, everybody. Thanks for coming out and coming over to this session. Just show of hands, how many of you are .NET developers? Hi, you're in the right place. This is a session. It's actually something I've been doing for the last 3 years. I've been at Amazon now for almost 4, and it's evolved quite a bit. Like, it started with just, hey, let's look at all the things on the Amazon platform that are interesting to .NET developers. Then last year I built a quick start, which I've now even enhanced further to make the experience of working with the services in Amazon, really easy to go ahead and just from your IDE, whether it be on a Mac, whether it be on a Windows box, whether using our workspaces, just make code changes and get out of the way as far as how hard is it to get everything up into AWS running inside of instances. I've also got Phil here with me, and he's from Webroot, and he's going to talk about their experience as they've gone over multi-years and they've brought their .NET applications into AWS. So, expectations. Just to kind of level set on what you'll be hearing, what you won't be hearing. You definitely are going to see a lot of conversation about .NET pipelines. I'm going to have 4 different pipelines to show you, some of which are using containers, some of which are using code deploy, but essentially all the same sort of interfacing for you as a developer from your IDE. Just click a button and let it go. We're not going to get deep into the tooling hooks. I will show you how we use a source control system like Visual Studio Team Services out online, but we're not going to really get into the detailed kind of build pipeline hooks. If you're interested in that, there's another session later today by Steve and Norm, who's on the tools team, and they're actually going to show some more investments that have been done, again, for .NET developers, meeting you kind of where the tools are. So I'm not going to go too deep into that. I mentioned you're going to hear from Webroot. We will end on time. You can see I had to edit that. And then we'll take questions if we have some time available. Every time I sat down to work on this session and these demos, this quote kept coming to mind. Who knows the movie it's from? Anyone? Shout it out. Ghostbusters, absolutely. Why am I thinking in these terms when I start looking at .NET and starting to deploy into AWS? It's not because there's an oil and water situation as it relates to targeting AWS. It's that I was working on my Mac. It's that I was running SQL Server in a Linux container, and then I was deploying that through into Linux environments, and I was doing all kinds of things that I've been a .NET developer for 15 years. I'd never, never really kind of went down that path in any significant way. I mean, there's been mono, there's been other ways to do that, but it just feels like the worlds have kind of shifted and changed, and that actually contributes a lot to the ability we have to help automate and deploy things directly into AWS. So let's just talk a little bit about classic versus core as I'm starting to think through these different models. And I talk to customers all the time. So the folks that are looking at AWS as a platform and are bringing .NET applications, not everyone is scorching the earth and running everything back in .NET Core. In fact, show of hands, who's got a production application in .NET Core? So there's some, right? But it's starting, right? This is sort of a new generation of kind of where the .NET developer is focusing. And it gives you this flexibility to be able to move in and out of different operating systems. But there's still problems and challenges, right? Security models are a bit of a challenge. And I'll show you kind of the aspects and elements of running a .NET Core application on Amazon Linux that it requires things like Nginx, requires a lot of the stuff that your classic PHP, LAMP stack developers have been doing for years and years and years, but now as you bring .NET Core applications and run them in production, you've got some more things to think about. Classic applications aren't going away though, and you still in some cases want to migrate and move those into AWS. And you may even want to modernize them leveraging containers. So we'll talk about that, and we'll show how kind of starting from a pipeline and working on your CI/CD can get you in a path of starting to kind of rethink what are the right components, how do I start to decompose this monolithic, potentially legacy application, because they're not going away, and you still want to try to move and enhance them. Okay, So deployment models, and some of these are old, they've been there for a while, so they've evolved, but there's different styles and strategies. AMI baking, right? Going in and installing all of the aspects that you need to run your application on the AMI. What's really powerful about this? It's super, super fast in terms of starting up and actually running and scaling and adding additional instances, and that's because all the dependencies are already sitting on the machine itself. Windows, in some cases, kind of puts you in this path a little bit because some of the stuff is relatively heavy, right? There's some density to the dependencies that exist for, say, an ASP.NET application or a SQL Server database or some of the things that you've got to go out and build. So in a lot of cases, you know, this is an old school strategy, but still super relevant. In fact, if any of you saw the session from the ECS team where they have now got an AMI that's been effectively baked so that it has some of the base layers out there for doing Windows container work. Why? Because it's just heavy. It's heavy to start to pull that stuff in dynamically. That said, you can draw a seam, draw a line somewhere so that you can do the bootstrapping and automation and not have so much maintenance, right? I think that's the biggest downside that you deal with AMI baking is the process that you have to institute to go in and make changes and version things. Docker, welcome to the party. This has been a growing deployment mechanism and model. Who's doing, show of hands again, who's doing a lot of Docker work today? And so that's even a little less than .NET Core, and I think some of these things are starting to bring about, again, some of that changing of kind of how you architect and think about the components that you want to design and deliver. At the bottom, you see this thing, 12 factors, right? So if you remember the old kind of conversations about building services and reusability, well, now 12 factors is a way to sort of really kind of hone in on what are the right things to do for my application. So now the containers are a thing on Windows, you can start to move in that direction. You can start to build out containers as part of your deployment pipeline, and I'll show you that today. So code deploy. Code deploy is an agent-based solution. It can run on premises, it can run in EC2, it can run on Windows, it can run on Linux. Essentially, it's a way to feed your code assets and run that last mile with a bunch of automation hooks, right? So there's automation in your bootstrapping of your AMI, and then there's automation that you may want to iterate on with a code package, right? An actual deployment of your code. So this gives you a bit more flexibility, and in fact, this was what I showed last year, and automated all of the build out, the CI/CD pipeline for Windows that you can go find online in the quick starts, that leverages code deploy because that gives you a nice model for making changes and feeding them all the way through a pipeline. Scales like you wouldn't believe, right? So you can go not from 5, 6, 7 thousands of instances, deploy all this out, and make decisions about how you want those to be deployed. All at once, one at a time, rolling, lots of flexibility here. Beanstalk, this has been kind of the classic, I do .NET stuff and I want to bring it into AWS, what do I use? For a long time, it's been Beanstalk, and Beanstalk just gives you additional guardrails. Right? It's going to take that sort of standard best practices design for a highly available API or web application, and it's going to put a load balancer in front of it. It's going to move it across availability zones. You know, you really end up in a situation where I'm just working on my code and I don't really want to have to kind of manage or deal with or think about some of the things that are going on the AWS side. So that's Beanstalk. Okay. Now, pipelines. And I'm not going to talk forever. I'm going to go about another 5 minutes or so, and then I'm going to demo. I've got those 4 pipelines I want to show you. So what are these pipelines? What are the different types of pipelines? And this isn't, I mean, I say .NET pipelines, but really it's any code pipeline. We can talk about hybrid configurations. Hybrid configurations, in my mind, are leveraging source control that either stays on premises or lives somewhere else, but then drawing into the tools at some point, right? So not necessarily all running native, which is the second option that I'm going to describe. Native would be, and we have all the assets you need, right? We have a code commit service where you can use it for source control, integrated with Git, so your tools can all use that directly. And then code commit works with code build, which works with code deploy, which works with all the different aspects that you would be looking for to completely leave it in a Amazon. It's an Amazon problem, right? You're going to scale at Amazon, you're going to manage it, you're going to patch it, you're going to deal with it. That's a native pipeline. So you really, native in the sense it's a native to the platform that you're targeting. And then there's the tool-driven styles. And you know, Phil's going to talk a little bit about some of the work they've done that's very, very focused on tools and tools like TeamCity. Jenkins is another very popular one. I think the biggest difference here between tool-driven and hybrid is just really where you draw the line. And so what I said earlier, going to Norm and Steve's session later, you'll see, hey, like, let's just use VSTS, TFS, and then just add the plugins and hooks to push to AWS at the last possible moment and keep all of your orchestration work in the tool itself. Same could be said of doing all that in Jenkins. Same could be said of doing all that in TeamCity. So 3 different types. Now, what makes a pipeline good or bad, right? Let's scorecard this out a little bit. Good would be repeatable, consistent, because you got to develop a certain degree of trust if you want to improve velocity in what you're rolling out into the production environment potentially, right? I wouldn't say it's good or bad to say the pipeline goes all the way through to production, because we'll talk in a minute about incorporating governance and gates and all the things that make sense to have division of responsibility, right? So there's a lot of different ways that you can make your pipeline trustworthy. What's bad? Like I say, avoid the snowflake syndrome, right? So maybe you've got 10 project teams. They've all got their own pipelines. They're all completely different. So anytime somebody needs to troubleshoot it, they've got to completely learn all the intricate details of what's going on in each different one. Now, you know, there can be deviation. Like, I don't have any problem with it deviating a little bit, but you do want some consistency so it's easy to manage. But then you got to avoid it becoming overly opaque and difficult to troubleshoot because there's so many moving parts. So it's simple, consistent, repeatable. In my mind, that's when you start to check all the boxes of high quality pipelines. So gates, you see I'm wearing my Counting Crows t-shirt. I thought that would tie together with this slide quite nicely. I look at these all the time, and I always want to make sure people don't walk away from a session where we talk about pipelines and automation with the sense that everybody's going to just make a change and it's going to immediately go to production, and that's the only manner in which I can do this kind of work. In fact, our pipeline service gives you a way to incorporate manual approvals. So you could at any point incorporate a decision maker, an authority that makes the call. Like in this case, if they know there's a potential issue with a developer code check-in, they may trigger a review. Obviously, that's probably a little bit less than consistent and repeatable. That's a bit of an opportunistic thing that we're doing there. But you get the point. Like, there's a lot of different ways that you can incorporate gates and then make sure that, let's say there's a change approval board that needs to look at something post-test, look at test results before triggering it to go to production. But the pipeline all stays together, right? Don't let it fragment and become a bunch of different pieces and parts. The tools. Now, these tools can be integrated into our services, like Pipeline, I'm going to talk about in a minute, and they all kind of have some of their own kind of nuances. They're all got their own ability to add. Like, for example, Jenkins is the one I'm most familiar with. Lots of plugins. Huge ecosystem there for you to be able to kind of do all kinds of MS build, automation work, depending on the versions that you're using. PowerShell can be incorporated very easily into Jenkins, and TeamCity as well, very flexible. And of course, Visual Studio. So Pipeline, another service to mention. This is the orchestrator. This one sits atop everything else and starts to drive all of the different stages and steps of your pipeline. So this has the ability to be fully extended via a concept called custom action types. And I'll show you that. That's how I've incorporated Jenkins to allow for a build to occur and actually create containers on the Jenkins server itself. So this is a nice way to actually get some of that consistency and visibility as things are flowing through. Code Build, one of the things I really want to mention here, make sure everyone understands, Code Build recently made it an option for you to run .NET Core builds. Now I've got a build server that I don't have to install it, I don't have to patch it, I don't have to maintain it, I don't have to do anything with it. I can just run through a build specification, and if that's .NET Core focused, in this case we have 1.0 today, but it'll continue to upgrade. This is new. There's also Docker-based images there. So we're essentially using Docker to build Docker. I mean, it's a little bit of a rabbit hole kind of a thing to describe, but you make the choice as to what image you want to run in Code Build, and you feed it the information, and it spews out the artifact. artifacts. So you can go through and do that build, and then take the output, and then you can deploy it with whatever mechanism makes the most sense, be it CloudFormation, be it code deploy, be it maybe, in fact, I'll show you one where I use code build to actually deploy, which is kind of an interesting way to go about that. CodeStar, who's heard of CodeStar? Not many, it's relatively new, right? So CodeStar, you may be wondering when you see my demo, did you not just reinvent the whole concept of CodeStar a little bit there, which was not my intent at all. CodeStar gives you a way to create a project. Think of it like the full-on kind of all-encompassing project that you put into like Visual Studio TFS, or you're going to go in and have a team member. You're going to have all kinds of things to kind of coordinate and work through. And then all these things that you're going to see me show, the code pipeline, the code deploy, all that configuration and setup is done on your behalf. It's fully integrated into the tool itself, so like Visual Studio, the IDE. So you just go in and you use the toolkit, the add-on, and then you have CodeStar there available for you. So the thing is, you don't have necessarily the same flexibility to change the repository where your source code lives, or kind of tweak and tune some of the things that are on the back end of the pipeline. It's very much kind of, think of it like a little bit like Beanstalk, in the sense that it's given you all of this kind of templatized way of working with AWS on the back end, and it's hooked into your tools. So it's similar, but it is different. Okay, couple interesting notes before I go jumping in. Git webhooks are pretty cool. This is what allowed me to take VSTS and make a source code change and immediately push it through. You create Git credentials, you can create personal access tokens. There's a lot of power in the ability to just add these quick little extensible hooks. Quick starts from AWS are built by our partner team and often leverage solution architects that are deep in specific areas. Like for me, it's been .NET, and it's been focusing on helping with this backend pipeline build out, and I've been doing it for a couple of years, so I've contributed quite a bit. But one of them that I found here was someone wrote this Git to S3 quick start, which deploys an API gateway instance. If you're not familiar with that, that's a front end into Lambda. So now I can execute these webhooks directly in and slurp down every code change and put it into S3, which then is basically our Swiss Army knife for driving the pipeline. So the quick starts are a real good way to get started, and then you can start to enhance and change and tweak different things. We want you to be in a position to choose. Right? That's, at the end of the day, I think AWS as a platform is highly flexible, a lot about building blocks and choice. So you'll be able to go in, and if you come to the session later, you'll be able to say, listen, I don't want to have to even build all that stuff, just let the tool do its thing, and I'll use these plugins that the AWS team is writing. Or you can come in and start looking at containerized deployments, and you can use these different pipeline mechanisms. So all of that should be leading me into demo land. All right. And I've timed out. And I'm switching. Okay, so got my cheat sheet over here. Let's go ahead and start by taking a look at Visual Studio Team Services. So this is VSTS, but I'm really only using it as a code repository here. Now what I've got is I've got a couple of different projects. One is a core project. One is a classic, so if I were to switch over to that, which I'm not going to bother, it's just, you'll see it in the actual development environment. You've got your ASP.NET Core running on my Mac here, right? And that one has got, you know, .NET Core and all the stuff that you need to run .NET Core, including some Docker files and some other things. But what I wanted to be able to do was this integration. I wanted to be able to go in and use a hook to go in and actually, when code changes occur, I want to push it directly there. So in here, you'll see these service hooks. So in these service hooks, we are able to, and I'll just go into edit mode. It's already up and running. You can see I've run through it more than a few times. But I'm able to choose, you know, at what level do I want to push new changes. Maybe it's every time a work item is updated. Maybe it's really, this is kind of your choice as to where you want to sort of enter into the mode of kickoff over to AWS, a trigger. Essentially, it's an event that then uses a lambda function to come back and pull the zip file down. And all of that's just available to you because Git has a REST API that you can make calls to, and it'll go ahead and do that. So Another thing to notice here is the actual API gateway itself, and I'll go ahead and show you that on the AWS side. So I'll cancel this. I don't want to change it because then everything gets broken. Now over here on the AWS side, you can see the management console, and in the management console, I've got this deployed, in fact, in 2 different regions. So these APIs are running in a specific region. They're configured and set up to go ahead and pull in for this pipeline, and API gateway right here. And VSTS webhooks is my API gateway. Now I didn't build this all out. I just went ahead and downloaded it. But go ahead and take a look at the actual execution flow. So API Gateway as a product allows you to do mapping of the input parameters, allows you to do authentication. When you configure and set this up, you store a personal access token, and then that gives me the ability to make the calls back into Git online, which actually, believe it or not, is the same model as a TFS. So the only difference, and the reason why I went down this path, is I really didn't feel like setting up a TFS server and getting all that kind of going, but the code and the manner in which it executes would be exactly the same. So the other thing to note is the Lambda function itself. So Lambda, if you're not familiar with Lambda, this is serverless mode stuff, right? This is just on the back end. Now it's written in Python, it's not written in C#, although that would be an option for you. Where is my download zip? Now you do get options to make code changes in line, or you can make code changes and zip them up and upload them to S3. This is just easier to take a look at. And what I actually did about a month or so ago is I added this new host flavor. So you can also see there's GitLab in here, Bitbucket, other options as well. And they're all sort of their own little animals, because you've got to go in and look at the actual, in fact, if you're really interested, this is what that JSON looks like here. If you can read that. That's essentially the parsing you've got to do to go figure out, okay, a code change triggered, what information do I need to pull together this zip URL, and then download that and throw it into S3. So while we're doing this, I got some other things to show you, and what I want to do is go ahead and trigger a code change. In fact, a couple different things to note. I've also got Docker for my Mac running on here, so you could do that on Windows as well, and I'll show you that here in a second. But Docker is able to do all kinds of cool things. Like in here you can see I've got a container executing right now, a SQL Server database. Would I run Docker in a production environment for a SQL Server database? No, not particularly. Like that's not necessarily something I feel super confident in doing because of a lot of different reasons. The idea of Docker as a way to kind of build portable components and do all this stuff for CI/CD though is super attractive to me, because now I don't ever have to really run the installation routines of SQL Server. Kind of the same concepts have existed for like building virtual machine images, but the ecosystem out in Docker Hub continues to grow. So you've got all kinds of Microsoft stuff out there now, and Microsoft themselves is producing official images and making them available for developers. So there's a lot of cool stuff there. So I'm running this little SQL Server database. I don't even need to go and create a server or an environment or an instance, and I can just run a quick test. Like I can just go ahead, in fact, I think it's already up and running. Visual Studio for my Mac is going to build real quick, and it's going to run, and you can see this is also another Docker file that goes ahead, and I don't run it as a Docker file in this case because I'm just using my local development environment, and I've got this simple little application right here that I can go and troubleshoot and do all kinds of cool stuff. So I can go ahead and just target the local host. Yes, I use the SA account. Such a hack. So this application is kind of meant to represent. I coach my seven-year-old's soccer team, and we only let certain folks get on the actual all-star based on the number of goals. It's a synthetic kind of thing, but I always use this to show kind of changes, and it's fun when my kids go and see it. They think I'm building something for them. All right. So coming back, what do I got? I've got that up and running. I've got that hitting a local Linux instance. Now, let's go ahead and kind of get out of that kind of developer mode. Actually, let me go ahead and make a change in here. Let's see. Maybe we're going to go in and what should I do? How about I go to the view? And I'll go into this home controller, and let's see here. Let's go ahead and change. That's not the one I want. This guy. Right, so the current logic is I want only over 12, but let's get more friendly and let everybody over 5 goals get through. So now I go ahead and make this change, save it, and I'm going to go ahead and publish it. So version control, let's go ahead and push changes. Hold on, where'd we go? Oh, it's up here. Review source. Yeah, I gotta first make my commit, whatever, and then push the changes immediately. And push them, and they go. So I'm already kind of logged in. I'm already integrated here. It's going to kickstart things on the other side. And while we're waiting for that, which it happens relatively quick, but let's take a look at these pipelines. So I have 2 pipelines that have been built out. One that's focused on using just basically .NET Core and code deploy to push all the way through and execute. So it hasn't started yet. You can see I ran it an hour ago. Basically, this is polling. So the configuration of this is set up to have a source repository, and then it's set to just look at this zip file that lives in S3. Now what happens is when those code changes occur and it hits those hooks and it puts it into S3, well, there's a new version. It's identified as a new version because there's been a change, and then this is polling and it'll trigger this full pipeline. So looking at that, that's one thing to kind of note. Another thing to note is what is set up inside of code build. So here, code build is a fully managed service. Now, when you do some of this stuff, you do end up kind of jumping around a little bit, so bear with me. I'll jump over into code build and look at the actual project details so you can see, actually you can see it's in progress right now, it's actually running. So over here you can see .NET Core is the actual image, which is running on Ubuntu, and it's basically the .NET process for building and publishing, and I feed that a build spec. So this build spec file right here, which, fun fact, Visual Studio for your Mac likes to jack with the encodings, so you have to be a little careful about this. I do every now and then, if I make changes, I have to put this into Sublime and save it as UTF-8, and there's some changes there that you just deal with some of these kind of challenges from time to time. But this build spec is really not super complex, right? It's just running the .NET restore, which is pulling in all the packages, the dependencies, and then it's going to run the publish, which goes ahead and builds the code and drops that into an output location, and then I copy those artifacts up. Now what Code Pipeline does is it uses its own encrypted S3 repository with these different artifacts as it's moving down through the pipeline. So once that's done, I come back here and I can go back to my pipeline. Let's get out of here, okay? And then the last thing I have is code deploy. And code deploy is actually triggered via another file, an app spec YAML. Now this is where I had to go in and run the supervisor restarting, similar to like if you were writing PowerShell for doing it against like an IS server. In this case, I'm actually restarting the .NET process itself after I've made code changes, and then everything kind of gets refreshed and updated. So this is all of the management of pushing these things through code deploy. Now, what I want to quickly do is also show you what's there for the other code pipeline, which is containers, right? So in this one, it's all going to execute and run through. You can see here that we've got the same source. In fact, I use the actual same exact source location. So it's triggering both pipelines in parallel, so I can push one to a containerized environment and one to this code deploy environment. I don't know that you would necessarily have that for yourself, but I wanted to represent the different ways in which you could do this stuff with .NET Core and Linux. So now, code build though is a little different because with code build, I'm gonna do the same step of creating the actual, the actual artifacts, the published artifacts, but I'm gonna do something different to actually put it into a container registry. This is not a deep conversation on containers. There's plenty of those here this week, and you can watch them on YouTube later. But a registry is where you can push an updated packaged container, version it, and then you've got this ability to kind of move it into a AWS cluster by just pointing at the new version of it. So this is where things like the Docker files start to come into play. So if I come back here, and I had that open already, I believe, you saw that here. That Docker file is leveraged to build out these containers, and then I can push that into the container registry, and that's just a command. It's a very simple command. So here, I'll go jump into that project detail. And this will get a lot faster when I show you the version of it on Windows, but I definitely want you to see that there's different ways in which it can be built out. So here, the thing that's kind of tricky is I couldn't have two build spec YAML files. So here you can do just inline commands. The reason I wanted to use this is because it's an already pre-built Docker image that has all the Docker tools on it. So I didn't have to go install any kind of bits. Like it's just all there running and managed. And then at the end, the last thing I use is a simple, I actually use code build as a service as the last step. And that is another project that I'll show you. This one is a little bit fancier in that it goes through and actually does Docker Compose. So if you're not familiar with Docker Compose, if you've done anything with Docker and worked on Visual Studio, you notice they've added Docker support. It's just a button you click on. They actually generate and create a Docker Compose file, and then when you run locally, it actually debugs in the Docker container environment. So Docker Compose is really powerful, and in fact, we have in our CLI for ECS the ability to let you just use the Docker Compose file. And then on the back end, we create task definitions. And again, I'm not going to get into the whole kind of translation that's necessary between the two. But this, you can just see real quickly, I'm running a Docker Compose. I even have a load balancer in front of it and some other things, so I can just quickly go in and update and make changes all from the same file. And that file comes through with updated changes to push to the latest version of the actual container. Okay, so that's all executing and running. We should be pretty much through there at this point. It takes about 5 or 6 minutes. I think I talked that long. Right? Okay, succeeded just now, so everything is through on the other side. And we should be able to see in my instance, .NET Core. I believe it's this one. Sorry. Here we go. That's the localhost one. Dur. Right. I think it's this one. Yeah. Okay. So we went through. We made a code change. I didn't touch anything. All the way through into an EC2 instance that has all the .NET Core stuff built out on it. Now, how am I going to do this for .NET Classic? What I just did is I clicked on a workspace. If you're not familiar with workspaces, that's a way in which you can run a virtual desktop environment. And I installed Visual Studio 2017 on it, and I've got everything I need to start to build out and execute, even with containers. So take a look at this. So on this environment, I've got Docker running. Let me see here. There we go. And I go to settings. I just want you to see some of what's set up in here. One of the things too, for those of you that are getting into this for the first time, I want you to see some of these changes I had to make. By default, when I installed it, a couple of weird things. By default, when you install it, the Docker's kind of de facto set to Linux. It's just, that's what it thinks everything is. So even when you install it with a Windows installation routine, you have to go flip it into Windows mode. The other thing is it likes to store all these images. And an image, think of it like a virtual machine, right? It's a pretty hefty thing. In fact, if I showed you, one of the things that's a little bit of a challenge is these images are hefty, right? They're up to 15 gigs in some cases, you can see right here. And really, I'm just running basic, in fact, SQL's smaller, but these are no longer those Linux versions. These aren't the nano versions. These are like what you would need to do your classic .NET application stuff. So it's It's great in the sense that you can be doing similar type of development work and pipeline work because you could be using containers both with your classic stuff and with new .NET Core stuff. But there are some things to recognize. This is also running and pushing through to a ECS environment, which is using a optimized AMI that we have recently announced that's for running Windows containers. So it's all set up, and it's as fast as it can be, given the fact that physics is not changing and moving that amount of data. It can be heavy. But if you're not familiar with Docker, do recognize that once this stuff is local and cached, it reuses it for all the other instances that are going to execute and run on there. So like you've got the same core layers for ASP.NET and IIS, and maybe you run 5 or 10 different containers, and they're going to share all that cached layering, and then just a small write-only shim is on top of it. So you do get some efficiencies. You get some speed. The other thing to note here. Let's come back. I actually deployed all these pipelines. I deployed these over in Oregon, just because I didn't want it to get all crowded. There's no real particular reason for it. Actually, some of the early beta work we were doing, this is where the Windows container stuff was available, so that also pushed me over in that path. But in here you see I've got these assets deployed out again. I actually used my old quick start to get the build server set up and to get the actual test server set up. Now the build server for Windows is where I've got to go in and do Jenkins. Right? So here's my Jenkins environment. If you haven't worked a lot with Jenkins, it's really easy to install and get moving. There are different types of projects here. This one actually did require Windows Server 2016 because I couldn't put Docker on it unless I had Windows Server 2016. But take a look at this project. They're called workspaces, and as I go through the pipeline, I pull down that zip file, we go through and we put that right on the file system of the Jenkins box, and then it triggers and runs these builds based on a code pipeline configuration. So we've written this. This is available to download and set up via the plugin model in Jenkins, and it's essentially going to pull and look at these APIs from code pipeline and say, oh, it's my turn to go run a build. And so this is that custom action type that I was describing earlier. This is, in fact, I've done the same thing with TeamCity. Like it can set up and the code pipeline can then pull in and do whatever you want to do in terms of build. Now, down here is where things become containerized. So right here, Visual Studio, MS Build, like you're able to download and install just the build tools now. Like that wasn't a real easy thing to do in the past. And in terms of best practices, you really don't want your build server to have a full-blown Visual Studio environment installed on it. So this is a nice way to just put those code tools on there, go through a build, and then you can go ahead and just put the output artifacts and publish them dynamically. Now, what I had done previously, like last year, I'd done some work where I actually hand authored a CS project file and sort of drove but it became very difficult for customers to use that. Because when they went and looked at it, like, wait, do I have to kind of author all of my own project file? Well, no, you really don't. Like just feed it the project file and just execute MS Build and do a publish. So then you have all the elements that you need. Now, what I've done down here is I've run some PowerShell stuff. PowerShell is beautiful for invoking some of these commands. So what that one is actually logging into our container repository. So now I've got my login credentials from Jenkins so I can push this new image directly into the container repository, which I'll show you in a second. And then down here, it's the Docker build and publish. This actually is a plugin from CloudBees, all free stuff, and you can go in and take a look. It's got automatic build numbering being added as a tag, so I can actually move forward and backwards with my Docker container. And then I just have this URL, and then I end with a little bit of is an interesting little hack I did here. I wrote a little regex thing that can update the CloudFormation template, because what I wanted to do is as this gets deployed to a new repository, I then wanted to trigger a CloudFormation template, which is the last step in my pipeline. So now I've got the new updated container, I've pushed it all out into the repository, I trigger CloudFormation, and again, end to end, and I didn't touch anything other than I made the code change. So we do plan to package all this up. I kind of got it all working right now in 4 different modes. We'll package this up in the near future and make it like the same kind of quick start that I described earlier, where you can download, install all these bits, and then tweak them and tune them however you like. The last step here is just the actual build push. So at the end of this build pipeline here, you're going to push it back through the code pipeline, and then it has this app build, which is how I pull in the actual YAML file to run CloudFormation updates. So I got a couple more things to show you. Over here, let's go take a look at my cluster, my ECS cluster, which is just 2 instances. Come on. There we go. So there's the container service. So inside here, remember I mentioned these repositories. So in these repositories, you'll see .NET Classic and the SQL Server environment that I was telling you about that I execute and run. So inside of there, if I click on that, you'll see all the different versions. So I don't know why it doesn't default to this strategy, but you can see I've run this 68 times. So I do a lot of testing of these pipelines. It breaks, I fix it, it breaks, I fix it, that kind of thing. But now you can sort of see all the history of what's been going on, and if you're looking for the most rapid way to fail back, this is a really awesome thing, right? Because that's just stored there for as long as you want to retain it, and then you can move forward and backward. Lots of interesting deployment models on top of containers as well. Like this is configured in such a way where I can deploy a new version, and there's some really interesting work my colleagues have done where they'll run a Lambda function to do a blue-green flip. And it's just taking the load balancer and changing a target group from one to another, and then it's instantaneous, right? And then tear down the other one when you're ready. Right, so it's not a very hard thing to start to incorporate blue-green testing because you're really not scorching everything. You're just adding to it, going a little bit beyond what was maybe the capacity that you necessarily needed so that you can keep iterating very quickly. So that's that, and then in the clusters you'll see, you know, I don't have anything running at the moment because I haven't pushed that one through. This one takes a little longer. Like I said, it's a little bit heavier, so it takes a good 10 minutes or so. So I'm not going to execute it right now because we'll never see it finish. But here you can see a version of another task that I was building out, and that one is just running a simple HTML page. So all this stuff is all stored and available here for you to version and maintain. And this is all, you know, really new capabilities inside of AWS to be able to do Windows-focused containers. So let me see, what have I forgotten? I've got a little cheat sheet here. We refreshed the app. We looked at the different pipelines. Yeah, I don't think there was anything else because I showed you the Jenkins server. So anyway, okay, so that's kind of, I'll call it a wrap there. There's 4 different pipelines you just saw, 2 of which are based on core, 2 of which are based on classic ASP.NET, 1 of which is using containers, 1 of which is using code deploy. It's about choice, right? It's about using whatever you think is the most comfortable mechanism for deploying all this stuff out, but it absolutely works end to end, and the integration with the development environment makes it feel like it's just a platform for you to deploy to. It's not necessarily some sort of secondary thing that you've got to go out and configure and set everything up from the ground floor. Once it's in play, you can just start iterating very quickly. So I'm going to hand it over to Phil at this point, and he's going to go in and talk about some of the work they've done at Webroot.
Thanks,
Switch
Tom.
this over. Here
we are.
Yes.
Hey, guys. My name is Phil Cohenton. I'm the Senior Manager of Cloud Operations at Webroot. Just a little quick note about who Webroot is. We're a leader in cybersecurity. We've got products in endpoint security, network protection, threat intelligence, security awareness training, DNS protection, quite a few product sets that we've built over the years inside of Amazon in order to offer our customers with basically cloud-based security. Now, we've been around for a while. We've been around since 1997, so we are not a startup. And that's quite important because if you look at the demo we've just had, many companies come into .NET at different points and stages. Some of them are, new startup companies. That's great. They can take full-blown, advantage of all the latest and greatest things that Amazon's got to offer. Some companies are, established. They've already got their source control maybe on premises, or maybe they've moved it into the cloud. So we've come in from, a long history of having the old guard sort of way of doing things and slowly moving it to sort of a modernized way. So that's why I want to sort of share the story really quickly with you guys. And the Webroot that we know today is the result of a couple of transformations through acquisitions we have a few years ago. One of them was a company called Prevex. So Prevex is the company I come from. And we basically built a cloud endpoint security running from like cloud-based, or private cloud at first, where we eventually adopted Amazon quite a while back. I think it was about 9 years ago now, where we moved into Amazon. And then we also had a company called Bright Cloud, which is basically excels at IP reputation and threat intelligence using machine learning. And again, all this kind of stuff is running inside the cloud. So I'm going to talk about the part that I sort of work on. We got different teams all over the world. So my team works in the UK, and we basically have a multi-region Windows environment. So we're running Windows for our front end, we're running Windows for our back end, and we have .NET applications in IIS as well as on the actual back end web, data processors. And we basically have a lot of data coming in. So we have to handle like 10 billion file interpretation URL lookups every day, file lookups, signatures. We get a lot of behavioral data, and all this data gets ingested into AWS, and it all gets ingested using .NET applications running inside Windows on Amazon. We're a pretty big Windows user in Amazon, I think, actually. So, and overall, the last bit about the company, we've got 30 million endpoint licensed out there. We've got about 27 million OEM customers, about 10K of the MSP partners, and about 240,000 business customers out there. So there's a lot of data coming in. Let's move on to the Amazon stuff. So we made a journey to Amazon, like I said, in 2008. We were basically a little small software company running out of England, and we had a little cloud-based endpoint, little small endpoint you run on Windows, which was basically going to the cloud and doing lookups for malware. And we were growing. We wanted to grow. We wanted to do maybe a partnership with a big company. So we knew we had to scale really quickly. So we moved into AWS. We started off with 3 racks in data center, maybe 4. We moved into 3 AZs. We liked it really, really well. So then we did the Netflix style, and we went straight across 3 regions right away. So 9 availability zones in very little bit of time. And we started that journey in Windows right from day one. So obviously, Windows 2008. But since then, a lot of things have changed. But in 2008, Amazon was a very different company than what it is right now. So we had no SDK, quite challenging. There was no Amazon console, right? The way we developed was quite difficult because we used to have to develop locally. We used to have IAM credentials in order to basically pass around to the development environments. We didn't have sort of IAM roles running on EC2 instances the way you have nowadays. We had very limited Amazon services to actually build our deployment environments. And we also had multi-account as well as multi-region right from day one. So that made our deployment very, very challenging. So we do what everybody else does, which is just rewrote everything ourselves, right? Started off with created our own API framework so that we can talk to Amazon. We started creating loads and loads of deployment scripts so that we can get our code out into the different environments. If you can imagine, we had EC2, S3, SQS, SimpleDB, and maybe just 1 or 2 other services available back then. And we utilized as many services as possible to get that code out there. Now, this was a little bit before we actually started using just .NET. At the time, we were using Classic ASP. We were just introducing .NET, but we were still able to get all of that code out there into Amazon. But there weren't many tools out there to help us do the job, so we did a lot of our own tooling. We spent a lot of time doing our own sort of house cleaning, but we eventually got it quite stable. And it gave us a lot of time to basically start focusing on building products, and we built a lot of products on that platform. Now, while we were doing that, while we were building all these products, Amazon was changing. Amazon was just coming up with services left and right, DynamoDB, RDS. Autoscaling was just really, really mature at that point. So, we got all these new products up and running, so we had the time to start looking around and seeing, well, what should we be doing now? And we decided that we want to reinvent ourselves, both architecturally, but also in terms of how we build our code, how we deploy our code. So it was time for the next generation of our stacks. So we did it in a phased approach. The first phase was to basically adopt a build and deployment platform. So we choose TeamCity, and we chose TeamCity quite a while ago. And at the time, we didn't have things like code deploy. We didn't have still all the tools that we wanted to have, but we wanted to make that choice anyway. So we used TeamCity, but we were able to use RDS right from day one. So that was quite helpful because we had that sort of cloud assurance that our data was still quite secure. We also moved our source control into AWS, but it wasn't an AWS source control because that didn't exist yet. We also moved our developers into the cloud. Now, we didn't work on workspaces like Tom mentioned because we didn't have workspaces, but we put our developers straight onto EC2 instances. And the reason for that is because a lot of our applications were quite complex. And sometimes, because we weren't running containers locally or anything like that, the developer wanted to be able to sort of interface with another Amazon resource, like a DynamoDB table or an S3 bucket. So we were able to basically allow them to assume roles in order to interact with those resources while they checked out the code and ran it locally. So it worked quite well for us for a while. And we ended up replacing a lot of proprietary API framework code that we had before the SDK. We replaced that with the SDK. And then we also started using a lot of the CLI and PowerShell. PowerShell with the AWS SDK, really, really powerful because it just allows you to basically interface with Amazon in very, very easy ways than we used to have to before. You don't have to create and sign your own API requests and all that kind of stuff. So if you're using PowerShell, and if you're not using the SDK, definitely one to look at, because it just helps, sort of boost your tooling. But there's a lot of plugins nowadays available anyways with TeamCity. So at the end of the day, we ended up in a situation where, Tom mentioned this before, a lot of people were in this situation a few years ago, right? You check out your code, you build your code, you roll up a staging environment, you deploy your code to there, you do your testing, everything works fine. You deploy it to your production environment, you do all your testing, everything's fine, and what do? You bake an AMI, right? So we were in that model for a while, and it worked for us. But the problem is we were getting a lot of AMIs, a lot of launch configurations, so we still had a lot of house cleaning. A lot of pros, though, because our source control was now locked away in the cloud, accessible to our build environment. Our build environment was secured by RDS. But still, it wasn't too bad. So once again, we were stabilized, and we were like, OK, what's the next move? So the phase 2 was code deploy. So when we heard about code deploy, we were really, really excited, because what we could do now is we had our IIS running on Windows. We can use code deploy to get our stuff over there. We had our data processors, whether it's a service or a scheduled task, something that's running a .NET application to process data or manipulate data, we were able to use code deploy. So now we had one deployment mechanism to sort of target both of our styles of actual applications that were running in the cloud. And that drastically simplified our TeamCity deployment. So we had one pipeline. There was another advantage as well, is because we were using code deploy, we didn't have to bake these AMIs all the time. And the concept of AMI baking became a completely different responsibility. It was just about creating that secure and most updated AMI, which had nothing to do with code and deployment anymore. So we were able to sort of drop that off and focus on getting our actual just code out into the environments. Phase 3, we were now stable. We had those the single deployment mechanisms out there: code deploy for our web applications, code deploy for our data processors. We're looking around. What's everybody doing? Everybody's got Docker. Everybody's running Linux, and they're running very, very cheap clustered container services. And we're like, it'd be nice to do that, but obviously, this is several years ago. We still didn't have Windows container services. We certainly, .NET wasn't nearly where it is right now, but we wanted in. So we played around, and our .NET applications are pretty much all C#. And Tom mentioned this one before, Mono, right? So we found a way, we tried it out and said, our code runs quite well on Mono. So at first, what we did is we still kept our code deploy, but going to Linux instances instead of going to Windows instances. That gave us a nice sort of cost advantage. And we were able to still have our auto-scaling teams. And once we were happy with that and stable with that, we just said, OK, let's take this off and move it over to ECS. And that worked quite well. So now we've got back to having not one deployment mechanism, we have two, but there's advantages on having both. So our web servers are still doing code deployed to auto-scaling teams, running IIS on Windows. And then for the data processors or the scheduled tasks and the services, they're running on Linux, ECS, and we have TeamCity building our actual containers, just like you would in Jenkins, uploading those containers and then updating the register, and life is quite good. So there was a couple of challenges that we had at first when we used ECS, and that was around like security groups. So at first, you couldn't have different security groups for the containers, but it took like no time before Amazon came along and sort of fixed that problem. So once they fixed that, we were happy to just have like single clusters for different types of data processors, all accessing different types of data stores. So whether it was like an application going to Microsoft SQL, or it was an application going to Elasticsearch, we were happy to host all those into one environment. And they were all happy living together. So where that brings us today is we've got TeamCity. We also got some TFS environments, and we're going to hold on to TeamCity for quite a while now, because we're interacting with other parts of the company where we're trying to get their code deploy going through our environment. So we're quite happy to stick there. We're not quite ready for .NET Core, but we use Amazon Code Deploy to get our stuff out into the Windows environments. We are still using IIS web services all over the place, and we are still using the ECS containers today, running Mono for our C# applications. And for operations, we're using a lot of Windows PowerShell now, and we're implementing all of the .NET code that we use inside our .NET applications, whether it's code to manage sort of pushing your CloudWatch metrics, or common code that we use from NuGet repositories for assuming roles. We can use that same code inside the PowerShell, which is a nice advantage for us. But now, we get to the end, it's like, well, what's the future plans for us? And this is the one thing. It's like, how can you know what your future plans are when you've just come from 2 keynotes at reInvent? I mean, it's always a game changer, right? You come here, you know exactly what you're going to do. You come out of the keynote, and you're like, oh, right, OK, well, that's going to change everything. It doesn't, though, because we sort of know where the future is going with Windows, right? We know that Windows container services are definitely on the rise. They're going to get better and better, and it's up to us to decide if, are we going to start morphing our code more into a .NET Core, or are we going to remain sort of classic for those applications that require that functionality? But that's the direction that we're going in, and we're also obviously going to be looking at serverless where it makes sense. But overall, that was our journey, from going old classic ASP inside classic environments all the way through to where we are now today. So I hope that was something that some people can relate to. That's it.
Okay, so we're kind of at like this last 5-minute mark. I thought of some other things I could show you, but I think maybe really just, is there any questions in the room? We can take questions for the last 5 minutes, or you guys can start rolling out if you're interested. One of the things I was going to show you was what it takes to install all of the bits for running .NET Core on Amazon Linux. So there's not really a lot of documentation and guidance on how to do that. So you really just go in and use the CentOS instructions and start installing all of the stuff based off of that. And all of those installers are available from Microsoft. So it went fairly well. There were some kind of bumps in the road, but I've got all that. That's more of what we'll package up and give everyone either via some sort of a blog post or a quick start, or maybe both, right? Like there's just a lot that I went through over the last 4 or 5 weeks getting those 4 pipelines up and running, and I think it is relatively early days with folks wanting to do a lot of these .NET Core deployments, so I think it'll be very useful. So I hope you had a good time. Thanks, Phil, for coming up and talking about the work you've done. Like I said, we'll stick around and answer questions, but at this point, we're good. Hey, enjoy the rest of the show.